Assalamu alaikum my dear students, how are you? Hope all of you are well by the grace of Almighty Allah. Welcome to NIEVS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National Ideal English Version School, Day Shift. Today I am going to take a physics class for class 9 students. My dear students, our today's topic chapter 4, Extra CQ 1, today's lecture number 6 and SW number 4. Now start our class chapter 4. This is chapter 4, work, power and energy. Extra CQ number 1. See this stem. An object with a mass of 250 gram is thrown vertically upward at 49 meter per second velocity. I am repeating, an object with a mass of 250 gram is thrown vertically upward at 49 meter per second velocity. My dear students, see here given the mass of an object is 250 gram. That means we have to convert this gram into kg, and it is thrown vertically upward at velocity 49 meter per second. That means velocity given 49 meter per second and it is thrown vertically upward. Now question number A, what is efficiency? Question number B, what is meant by the work done against the force? Question number C, how long will the body take to reach the maximum height? Question number D, show that the total energy of the body before throwing it is equal to its total energy at the maximum height. Now question number A, what is efficiency? We have already learned while reading the chapter. The efficiency means the ratio of the amount of work of a machine and the given energy is called its efficiency. My dear students, I am repeating, efficiency means the ratio of the amount of work of a machine and the given energy is called its efficiency. Efficiency equals to, the formula of efficiency is amount of work divided by energy given into 100. Now question number B, what is meant by the work done against the force? If a body moves in the opposite direction on application of a force, then the product of the force and distance covered is called work done against the force. For example, if a duster is raised up from the ground, the gravitational forces acts towards ground and displacement of the duster is in the opposite direction. So in this case, work is being done against the force of gravity. My dear students, I am repeating this question answer. If a body moves in the opposite direction on an application of a force, then the product of the force and distance covered is called work done against the force. For example, if a duster is raised up from the ground, the gravitational forces acts towards ground and displacement of duster is in the opposite direction. So in this case, work is being done against the force of gravity. Suppose this marker, if we raised this marker from the ground to the ground, the gravitational force acts downward, okay, and the displacement of duster is the opposite direction, that means upward. So the displacement of marker is upward and the gravitational acceleration acts downward. So this work is being against the force of gravity. This is called means the work done against the force. Now question number C, how long will the body take to reach the maximum height? My dear students, this CQ, that number C and is very important. I am repeating the number C, how long will the body take to reach the maximum height? Now we will solve this problem. Okay, at first see here given the velocity of body, that means u 49 meter per second according to stem. Okay, at maximum height velocity of body will be 0, that means v will be 0. So v equals to 0 meter per second. And gravitational acceleration we know g equals to 9.8 meter per second square, and time, that means we have to find out how long the body take to reach the maximum height. So we have to find out the time, t equals to what? Now right, here given the velocity of body, that means the initial velocity according to stem here given 49 meter per second. The maximum height, at maximum height, memorize properly, at maximum height the velocity of body v will be 0 meter per second, and we know g equals to 9.8 meter per second square, and we have to find out the time t, how long that time the body will take the reach at maximum height. Now we will write the formula. We know v equals to, this one is the against an object is thrown vertically upward, that means the acceleration, gravitational acceleration acts downward and the objects doing work in the opposite direction, that means this one is upward. So we have to use this formula, v equals to u minus gt. My dear students, in chapter 2 we already learnt that v equals to u plus at, and for negative work we will write v equals to u minus at, but in this chapter here instead of a we use g, okay, the gravitational acceleration. This one is also acceleration and g is gravitational acceleration. So in this chapter we will use v equals to u minus gt, this formula. Okay, now put the value v equals to u minus gt, here given v equals to 0, so v equals to 0, u means 49, g means 9.8 meter per second square, and we have to find out the t. So we write 49 minus 9.8, t equals to 0, that means we have to find out t. So minus 9.8, t equals to, here this is plus, and for changing this side we will write minus 49, that means minus vanish. So t equals to 49 divided by 9.8. So do the calculation, 49 divided by 9.8, it will be 5, and time it will be second, the unit of time is second. So 5 seconds, how long 5 seconds will take this body to reach the maximum height. My dear students, I hope all of you have understood this mathematical problem. Now question number D. We will solve question D now. Question number D. Show that the total energy of the body before throwing it is equal to its total energy at the maximum height. My dear students, see, total, we have to find out the total energy of the body before throwing. That means total energy means the total potential energy and kinetic energy. Okay, the addition of total energy and kinetic energy is the total energy before throwing, and total energy of at maximum height also means that we have to find out the potential energy and kinetic energy at the maximum height. Okay, and these two addition is will be the total energy of the maximum height. So now we write number D. Height before throwing the body, h equals to 0 meter. That means h equals to, before throwing the body, height is 0 meter and the velocity is 49. That means u, initial velocity u is 49 meter per second, and mass of the body m equals to, according to Stain, 250 gram. That means we will convert this gram into kg. That means 250 into 1000. That means 10 to the power minus 3 kg. Okay, and potential energy before throwing the body. We have to find out the potential energy before throwing the body and kinetic energy before throwing the body. So potential energy before throwing the body, it will be potential energy EP. Potential energy EP equals to mgh. The formula of potential energy equals to mgh. Now put the value. M means mass. The mass is 250 into 10 to the power minus 3 into g means 9.8 meter per second square, and h is 0. Height before throwing the body, it will be 0. So total potential energy will be 0 joule. Okay, now the kinetic energy before throwing the body. Kinetic energy is Ke. Okay, kinetic energy Ke or Ek equals to half mv square. The formula of kinetic energy is half mv square. So put the value half into m means 40, m means 250 into 10 to the power minus 3 into v means before throwing the body, v is 49. We will write before throwing, that's why we will write here u. So u is 49 whole square. Now do the calculation. It will be 300.125 joule. So my dear students, we already found the potential energy and the kinetic energy. So total energy will be total energy E. Suppose this one is E before, this one is the before throwing the body, E1. Okay, E1 equals to EP plus EK. So EP is 0 plus EK is 300.125 joule. That means 300.125 joule. This is the total energy before throwing the body. Now we have to similarly we have to find out the total energy at the maximum height. My dear students, now I will erase this one. At maximum height, the potential energy, now we will find out the at maximum height. So from part C, the time of reaching maximum height is 5 here. Time of height, maximum height, time is 5 seconds. From C, from part C, we found that t equals to 5 seconds. Okay, so if the maximum height is h, then we can write h equals to ut minus half gt square. My dear students, here we use s equals to, from chapter 2 we have learned that this formula s equal to ut plus half at square. Okay, just from this in this chapter we use h equals to ut plus half gt square. Instead of a we will use g, but this is the against force, this work done is against force, that's why we use minus. Okay, that's why we use minus. So h equals to ut minus half gt square. Okay, at maximum height, that's why we use capital H. So now for use the formula, u means 49 into t means 5 minus half into g means 9.8 meter per second square into t means 5 whole square. That means by doing this calculation we can find out 245 minus 122.5 equals to 122.5 meter. Okay, the maximum height it will be 122.5 meter. Now we will find out the potential energy at maximum height. Okay, so potential energy at maximum height EP equals to mgh. Now put the value. M means 250 into 10 to the power minus 3 into g means 9.8 into h means 122.5. That means it will be 300.125 joule. My dear students, this is the potential energy at maximum height. Now we will find out the kinetic energy before at maximum height. Kinetic energy at maximum height. So Ek equals to half mv square. At maximum height v will be 0. So half mv square equals to half into m means 250 into 10 to the power minus 3 into v is 0. So total kinetic energy will be 0. So, the total energy, what is the total energy? Total energy is E2 equals to EP plus EK. Okay. At maximum height, total energy E2 equals to EP plus EK. That means potential energy plus kinetic energy. So, potential energy is 300.125 plus kinetic energy is 0. So, it will be 300.125 joule. So, my dear students, from this above calculation, we can see that the total energy at the body throwing the total energy before throwing this body is equal to the total energy at the maximum height. That means 300.125 joule. So, I hope all of you have understood this calculation. Your today's SW number is 4 and this is X2C Q1 and number C and D. Do this as your SW and submit it on Saturday. My dear students, I hope all of you have understood our today's CQ. Practice properly at home. This is very important CQ. Submit SW regularly. See you again in the next class. Allah Hafiz.